Hello, and then welcome to Module 24, which is Mineral Resources and Geology. So today we're talking a little bit about earth science. So just a little bit of information. This is showing the formation of Earth, or not Earth, but actually our whole solar system. So you can see here's Earth here, the sun, and then you've got the other 8 planets. So basically, what happened is there's this constellation or concentration of dust and gas, and so this forms basically this. So I'll talk a little bit about that. But so this is this nebular cloud, and so these are gases that are present throughout the whole universe. So they condense because of gravity. They combine together. And they form bigger and bigger things. And it is rotating. We can see lots of nebular clouds rotating like this. And so eventually, and this is over, millions and millions of years that this is occurring. But gravity pulls these things together and it's circulating just like it was in here as a cloud of gas. And so these particles, these atoms join together and they form things that are solid, and they continue to do that until we're left with just the lighter gases like hydrogen and helium. And then the rest is forming the planets. And then the most concentration, so 99% of the gases are found within the center, which would be our center of gravity, which in every system would be a star. So in our case, this is the solar system. So this is the star, the sun in the center, and then Earth out here. And then, of course, like I said, the other planets. And then we've got all different kinds of other star systems that have formed planet systems as well. And so this is about 4.6 billion years ago. And we can look at the rock record and we can date the rock back that far. So we can use things like uranium dating, radon. Let's see. That's about the main things to date that far back would be using those things. And that's radiometric dating. So we can look at the half-life of those elements and we can figure out how long it's been since they formed. And so we can see the Earth, Mars, the moon, all of those are about 4.6 billion years old. And just a reminder, Earth is a closed system, meaning that things don't enter and leave. So think about what that means for resources. So if it's a closed system, that means that all the resources that are available for humans are found on the Earth right now. So we have no other resources outside of the Earth that we can readily use. All right, so if we look at the Earth and the structure, so we've got different layers of the Earth. So looking at the crust going inward, we have the crust, then we have the upper part of the mantle, which makes up the lithosphere. And so the lithosphere are the plates. You've probably heard of plates sliding around. So lithosphere is the plates. So crust and upper part of the mantle. And then we've got something called the asthenosphere below. And then below that, we've got the the outer and inner cores. And so that's our layers. And then if we look at the depths of these, so they're comparing this to the US here. So here's the crust. And remember, the lithosphere is the crust and upper part of the mantle. And then we've got the asthenosphere, which is kind of like the middle small portion of mantle. And then we've got the main mantle, which makes up all of this. So basically, right below the crust, all the way to the outer core is the mantle. And then you've got the outer core, inner core. So this space, the spacing, represents about the width of the US. And so you can see if we were to dig down from the crust, we would be digging down through the entire US down to the core. So that would be pretty far. So just be familiar with these things. Like I said, this is a lot of earth science, but we need to talk about it because we're going to talk about resources. And so resources come from the earth. But we've got the crust, mantle, core, lithosphere, asthenosphere. So just be familiar with those terms and where they're located. All right. So we've got something called plate tectonics, which is, like I said, the lithosphere, which is the crust and upper part of the mantle. Those are sliding around on the asthenosphere, and they're colliding and moving apart and doing all kinds of things. And that's creating volcanism. So volcanoes erupting, that's causing earthquakes. it's causing minerals to come to the surface that maybe otherwise didn't. So it's creating a lot of different things. But that's the theory of plate tectonics basically states how that is occurring. So how the mantle is convecting and the lithosphere on top of it is moving around and colliding and subducting and forming volcanoes and all kinds of things. All right, so here's our plates. So you can see there's quite a few plates. In the US here, what affects us the most for us in California is, in Northern California especially, is the Juan de Fuca plate. So this little tiny plate up here, and it's the cause of earthquakes that happen off of Eureka and Crescent City. So any earthquakes that we find happening there, and Eureka often gets earthquakes, that's because of the Juan de Fuca plate. So the Juan de Fuca plate is subducting, meaning going under the North American plate. So that's creating this subduction zone, which is why we have volcanoes like Lassen and Shasta in Northern California, but we don't have them in Southern California. And the reason we don't have them in Southern California is because the Juan de Fuca plate is up here only. And so down here we have sliding occurring. So the plates are like sliding past each other rather than going under. And so that would be the Pacific plate sliding along the North American plate, which is our San Andreas fault. So this is a different type of fault. It's sliding. It's a transform boundary. And so it's not creating volcanoes. Only the convergent boundary, which is the Juan de Fuca plate, is creating that. And you can see these little arrows are showing the movement of these plates all around the world. And that's plate tectonics. All right, so here is kind of what's happening. So mantle is convecting, and we've got this spreading, which is a divergent boundary. And then we've got the plate moving this direction, and eventually the Earth is not getting bigger. So eventually the plate is going to subduct, meaning going underneath. So this is a convergent boundary, and this is where we get volcanoes or uplift, like mountains. And then you can see over here, same thing is occurring. So we've got subduction occurring, we've got magma rising, we've got all of these volcanoes forming, and that's plate movement. All right. So something else that we see here is called a hotspot. And so a hotspot happens in the middle of a plate. So it's not on a plate boundary. It is a volcano. We've got a couple that are familiar to us. We've got Hawaii, and then we also have Yellowstone. So Yellowstone is a continental hotspot. So hotspots are basically just an area in the mantle that is extra hot, and it's melting through the plate. So as the plate moves along, the hot spot stays in the same place. So that mantle that is extra hot stays there, and then the plate is moving across, and so you get chains of islands, like the Hawaiian Islands, for example. And then we also get sometimes, like I said, a big volcano, which is Yellowstone. But mainly we get hotspots. So Hawaiian Islands are formed by these hotspots, which are just a hotter layer in the crust, or in the mantle, I mean. And then as the crust moves across, that magma seeps up through and creates these big, large volcanoes. All right, so if we look at Hawaii here, we can see this is millions of years past, but the hotspot is here. It's kind of like red in here. It's kind of both. So these islands used to be on the hotspot, but they have since moved on. They are not volcanic anymore, so they're not erupting. Hawaii is still erupting, and then we've got this new little volcano that is forming under the water. And so eventually, millions of years from now, it's probably going to be a new island. And so the direction of the plate movement is this direction. And so this is our oldest island that is above water, and this formed over this hotspot. And so this is our oldest one, this is our youngest one. And so it's moving in this direction. And that's how a hotspot works. All right, so there's 3 types of plate movements. You might have heard me mention them. We've got divergent, convergent, and transform. So divergent is when they're moving apart. So that would be where the plate is splitting. And then we've got convergent, where they're coming together. So a plate is colliding with another plate. And this is often where we get volcanoes. So we get volcanoes here too. Iceland is a great example of this. But here is like an example of Lassen or Shasta. So we've got melting occurring here, and that magma rises and forms the volcano here. And then here we've got a transform boundary. So transform means it's just sliding past. There's no volcanoes that occur because there's no subduction. There's no magma forming. And those are our three types. All right, so a couple other terms here. Fault is where you've got a break in the crust. And so that is usually where we find an earthquake. And then seismic activity is just the earthquake activity. So when the ground rumbles, that would be our seismic activity. And then a fault zone is just an area where we have lots of faults. So California is a great example. There's faults all over the place. And that's because we are near a couple different plate boundaries. We're near the Juan de Fuca, which is convergent. And then we're also near San Andreas, which is transform. And then here's how an earthquake works. An earthquake. So here we've got the focus, and then the energy is radiating out in all directions. And so where it's going to radiate out and meet the surface first is going to be the epicenter. And then from there, they might feel it out here, but it's going to be most intense here at the epicenter. And so when we measure earthquakes, we always talk about the epicenter. So where did it occur? Where was the epicenter? That's directly under the focus. So the focus is actually where it started, unless it started on the surface. But usually it starts on the fault line, which is not right on the surface. And then it radiates out in all directions like a ripple of a pond. And that forms the earthquake on the surface. And the Richter scale measures that. So the Richter scale is increasing by factors of 10. So that means 1 on the Richter scale versus a 2 is 10 times different. So you can see that's it's definitely like way stronger. So between like when we measure a 3.2 versus a 3.8, that's pretty considerably bigger, even though it doesn't seem like it. But they're factors of 10, kind of like the pH scale. All right, and then here's where we have our plate boundaries, but this is where it's showing a lot of different things. So it's showing plate boundaries, it's showing the types of plate boundaries, and it's also showing where we have volcanoes, hotspots, and then this area here is known as the Ring of Fire. So notice how most of our volcanoes, our little red triangles, occur along this area. So this is all subduction. The Pacific Ocean is actually going underneath all the other plates, and it's getting smaller. And the Atlantic Ocean is divergent boundaries, so they're splitting apart. And the Atlantic Ocean is actually getting bigger. So here we've got our little islands, our Hawaiian Islands, and that's formed by a hotspot. But most of the volcanoes along the Earth or on the Earth is formed along this area. And so it's called the Ring of Fire for that reason. All right, and then the rock cycle. Hopefully this is a review, maybe from junior high, or if you took earth science, then it should definitely be a review. But the rock cycle is igneous, metamorphic, and sedimentary. And then basically they're constantly changing. So a metamorphic rock is formed by heat and pressure. So if a sedimentary rock undergoes heat and pressure, it forms metamorphic. If an igneous rock undergoes heat and pressure, it forms metamorphic. If a rock melts and forms magma and then recrystallizes, it's igneous. If a rock crumbles and forms sediment and the sediment is squeezed together, then that's going to form sedimentary. And so sedimentary is formed by squeezing sediment together. Metamorphic is heat and pressure, not melting all the way though. So it melts partially, but not all the way. And then if it melts all the way, it's an igneous rock. So things are constantly changing. So they're constantly changing from these three types of rocks. There's nothing really ever stationary. Once these form, they're subjected to weathering. So they're going to weather and form sediment, and then eventually maybe a sedimentary rock, and so on. All right, so these three types, we've got igneous, metamorphic, and sedimentary to talk about, and then we're done. So intrusive igneous rock means that it forms inside the earth. So if we look at these pictures, think about intrusive is inside the earth, extrusive is outside the earth. Extrusive is going to have no variation in color, whereas intrusive will. So if we look at these pictures, this first one is intrusive. So the reason I know that is because there's variation in color, and those colors are minerals. And so if it cools slowly, then the minerals have time to join and meet up with the same minerals, and then they form colors. This is intrusive. I can see little white specks, so that would be formed inside. If you can see any kind of coloration at all, a variation, then it's intrusive, even if it's tiny. This one is intrusive. This one's extrusive. I see like lighter color, but it's not a variation. It's just lighter color. This has holes in it, but it's the same color. So this is extrusive also. And then this one is intrusive. This one's intrusive, intrusive. This one's hard to see in this picture, but if I see different minerals in it, then it's going to be intrusive, but I really don't. I see some coloring on it, but I don't think those are minerals. So I would say that would be extrusive. All right, so extrusive, no coloration, variation. And then intrusive, you would see crystals, or you would see a variation in color. All right, and then sedimentary are formed from sediment layers. So here's an example. So we can see often really distinct layers like this. And so that's a sedimentary rock. And this is the only type of rock that we find fossils in. And that's because these are formed from sediment. The other two rocks are formed from heat and pressure or magma. So a fossil would be destroyed in any situation like that. So sedimentary rock, when it's just layers of sediment laid down on top of other layers, is where we would find fossils. And the last one is metamorphic. So metamorphic is a changed rock. So metamorphism means change, just like a butterfly metamorphosize. So metamorphic means that it's been changed. So here we've got some examples of metamorphic. So we've got gneiss, slate, quartzite, which is formed from sand. This is formed from shale. This is formed from a rock called gabbro. And then schist, marble, and schist is a type of slate. It's just undergone more metamorphism. Marble is formed from limestone, and phyllite is also formed from slate. So it goes shale, slate, schist, phyllite. And so those are how they form in that order. So this has just undergone a lot more metamorphism than this has. And this has undergone even less than these two have. But these are all metamorphic rocks, so they're partially melted. So minerals don't melt at the same melting temperature. So if they partially melt, then only part of the rock, like kind of like a chocolate chip cookie, if you have it's hot, the chocolate chips melt, but the cookie doesn't. So it's kind of like that. So part of the rock will melt and then recrystallize, and that forms a metamorphic rock. Or it's undergoing heat pressure. So if it's undergoing squeezing, then it's going to cause metamorphism. If you go out to Whiskeytown Lake and you look at the rock layers, as you go out there and you drive and they've cut through the rock, you'll see the rock layers kind of do this like curvature, and you can see it out at Shasta too. And those are that's metamorphism. So metamorphism causes the layers, especially like sedimentary layers, to bend and buckle because it's undergoing heat and pressure. And that's it. So I will see you guys next.